Let's play a game. Focus on the status level of metallic. Now, I'm going to drink 4 potions made from 1 rockolio and an increasing number of scrap metal. When I drink a potion of 1 rockolio and 4 scrap metal, what would the status level of metallic be? Now, if you took note of them, then you'd probably get this set of data. So, what's the status level of that last potion right there? If you guessed 4.25, then you're wrong. It's actually 4.1. Because, I don't know, Pilgrim said so. But why is that? Good question. In fact, this one has haunted me in my nightmares for 4 months. See, in my last video, I intentionally left something out. We know how the effect of a potion scales as you add more of the same base ingredient. But, here's the thing. There are different base ingredients which give the same effect, like scrap metal and rockolio both giving metallic. Truth be told, if you use only one base, then honestly it's a-okay because you can guess the pattern very easily. But if for some reason you decide to mix and match base ingredients which give the same effect, then you'd be essentially opening a can of worms because oh my god, how do you solve this? Okay, it's not that bad, but compared to one base ingredient, it's harder. So this made me think, just what kind of abomination would I make if I decide to mix and match base ingredients? So I decided to embark on this journey to conquer the final bastion of potions, once and for all. And of course, the first thing I had to do was some data collection. And for my primary base, which is what I'll be calling the first type of base ingredient added, I opted for scrap metal. While my secondary base, which is my second type of base ingredient added, would be something that also gave metallic. This was because metallic gave essentially exact values, and that was particularly useful for reverse engineering equations and formulas. In fact, all the formulas I found for a status level in my first potions video were built on the foundation of this concept. Also, I had a ton of scrap metal to burn. Using scrap metal as my primary base, I got these values by changing my secondary base. And upon first glance, I mean, it seems ordinary enough. Firstly, we can see that these numbers don't extend indefinitely, meaning we don't need to worry about working with non-exact values. So that was very promising. In fact, this held true for larger amounts of base ingredients too. So after finding out the corresponding status levels from different potion combinations, I was stumped. I was hit with 3 immediate obstacles. And the first one was that I just wasn't sure what the new status level was dependent on. For scrap metal, the starting status level was 1, and the increase was 0.5. Whereas rockolios started at 2.25 and increased by 0.75. Now, as you can probably see, 1 scrap metal is weaker than 1 rockolio, so theoretically speaking, when you mix 1 rockolio and 1 scrap metal together, it should be stronger than 2 scrap metal. Yet we can see that this isn't the case. And if we substitute the rockolio for a stone flower, which is supposedly weaker than a rockolio but stronger than a scrap metal, we can see that this instead achieves the lowest status level out of the 3 combinations, which makes no sense. Why is it decreasing? In addition to this, the second obstacle was that the patterns of some potion combinations seemed to be random, like the example I gave in the beginning of the video with rockolio and scrap metal. Considering how all the terms increased by only 0.5 when compared to its last term, it makes no sense why the final term only has a 0.35 increase. And to add insult to injury, there was the third obstacle. And this third obstacle was more like a question. Whether using a mix of 2 different base ingredients that gave the exact same status levels would be the same as adding a lot of 1 base ingredient. The reason for this was because I wanted to know if only using 1 base was relevant to my investigation. Supposedly, the underlying principle status level abides by should be more or less the same. It's just that only using 1 base was a specific case that just so happened to have this special property. Similar to how a square is just a rectangle, but all sides are the same. If the mix of 2 different bases was the same as only using 1, then not only can I save on materials, but also demonstrate that only the status level mattered, as well as recognize that only using 1 base ingredient could be a clue in itself. So out of these 3 issues, I decided to tackle the third one first. Yellow jelly and lily cod share the same effect and status levels, so testing out the third obstacle was by far the easiest. Using 1 yellow jelly and 1 lily cod gave me a status level of 2, which lined up with only using 2 yellow jelly or lily cod. But once I increased the amount of lily cods from 1 to 2, it returned 2.31, which is not the same as free yellow jelly or lily cod. So this meant that the mechanics behind only using 1 base was different than using 2 or more, which was horrible news. Things just imploded in my face, wow. And after that, I was absolutely clueless. It was as though progress had hit a brick wall. I got hit with midterms too, which only further deterred me. Until one day, I received a ping from Xander telling me he had found something. It turns out I had completely forgotten about a 4th base ingredient that shared the exact same metallic status level as stoneflower, magma scale. Now this was pretty helpful because now I had access to reliable data in the form of exact values. So after midterms, I knew it was time for me to pick potions back up. Now I've never had the habit of organizing data and whatnot, but at this point I was losing my mind, so I just decided to start recording my data, just in case. I tested a ton of different combinations indicated by these shorthands in this document, which I linked in the description. It's the 3rd tab. And it seemed as though everything was nonsensical as ever. Like, what is this? I don't understand. Until there was something of note which happened to catch my eye. A clue of sorts. And it would be this clue that would lead me to unlock the mystery behind the first obstacle. The first obstacle was the unknown variable that dictated the increase in status level, and the clue for this actually lies in potion combinations that share the same status level. Let's take a look at this row. This row tells us that adding 1 magma scale and 1 rock oleo is the same as 2 scrap metal and 1 rock oleo. Now if you remember your potion equations, you'd know that 1 magma scale and 2 scrap give the same status level. So what this clue tells us is that the key to finding out the increase is actually in the preceding status level. With this information in hand, I discovered that the increase in status level scales linearly with the preceding status level when the amount of secondary base ingredients was kept constant, while changing the amount of secondary base ingredients changed the slope by affecting both the numerator and denominator, as well as the y-intercept of the linear equation. In case you want the equations for scrap metal, stoneflower, and rock oleo, here they are. I think you'll understand once you see them. This leads into our next obstacle, which would be the randomness of the pattern. Going back to our example at the start, if we compare the calculated results and the actual results, we can see that the equation does not hold for 1, 2, and 3 scrap, but it correctly predicts 4. Well, I suspect that secondary bases have an innate maximum value, with this max value being the increase you get when you add multiple of the same base ingredient. For example, when only scrap metal is used, metallic increases by 0.5 for every additional scrap metal, so the maximum increase is 0.5, while rock oleos would be 0.75. So when these ingredients are added after the primary base, the maximum increase they can give is 0.5 for scrap metal and 0.75 for rock oleo. Using this interpretation, we can now make quick work of that pattern from earlier. Now, using our equations, we can know that the theoretical value is around 3.21. So compared to the last term, the increase is around 0.97. Since that's above our maximum value of 0.5 for scrap metal, we have to cap this increase at 0.5. So we add 0.5 to 2.25 to get 2.75 when 1 scrap metal is added. Rinse and repeat this process for the cases where scrap metal is 2 and 3, and you'd see that the difference between the theoretical value and the last term is still larger than 0.5. And since it can't go above that, you just keep adding 0.5 to get 3.25 and 3.75 respectively. But then we reach the final case, which is for scrap metal. Now, our calculated value for the next status level would be 4.1, and if you calculate the difference between 4.1 and 3.75, the last term, you'd see that this difference is smaller than 0.5. And because of this, that's why the game accepts the value of 4.1 instead of 4.25. So that concludes our second obstacle. As for our third obstacle, it's pretty much been answered. As to why, I'm just gonna demonstrate it to you directly. Okay, I'm gonna completely ad-lib this part because I really think it's not that complicated. Now, for one scrap metal, it's just 1. So, yeah, I don't know what to say, it's just 1. Okay, for 2 scrap metal, it's 1 plus that other thing, like our scrap metal function. So, this is our first scrap metal, and this is our second scrap metal. So, the amount of secondary base ingredient is 1, and the preceding status level is also 1. So, as you can see, it correctly predicted the next term in our series. And after that, we just keep going. I'm just going to copy-paste this because I'm too lazy to actually type it out again. Now, done. Okay, now this 1 turns into a 2 because now we have 2 secondary base ingredients. So this is a 2, and this 1 becomes 1.5 because this term here is supposed to be the preceding status level, and as you can see, it correctly predicts it again. I know I think I'm going pretty fast here, but it's not hard, seriously. Okay, and rinse and repeat. This is 3 now, and this becomes 2, and now this is 4, and this is 2.5. And as you can see, all of this holds, so I really don't know what to say. Yeah, that's it. In any case, on the 26th of December, or Boxing Day of Christmas, I received the greatest Christmas gift of all. The answer to Pilgrammed Alchemy. Wait, what's that? Equations of potion sickness duration. Guys, while I was editing this video, the junk pits dropped and they gutted potion sickness. Before it was like 4 seconds, now it's like 16. So, I am very thankful that I did not even try to touch potion sickness. Otherwise, all my past research would have been for nothing. Yeah, junk pits is out. I'm gonna edit this as fast as possible. I mean the remaining parts, and then I'm gonna play the junk pits. We're so back. We're so back. Okay, this isn't the end I was intending on initially, but still, I just want to yap about junk pits. Okay, post-editing chili out here. Okay, goodbye. Anyway, quick thanks to Xander for providing me with this information, even though I wasn't particularly active then. Can you guess why? Ooh. Oh, and ZM, because he helped me test some potion combinations. And yeah, that's about it for the video. See you guys in the next one, which probably won't be soon because I still have a ton of stuff to do during summer. Bye.